Okay, welcome to another pre-AMC 8 video for SaMi. San Antonio Math Include. I'm Olivia, and let's get started. So we have 12 friends meet for dinner at Oscar's Overstuffed Oysters, and the portions were large enough for there to be enough food for 18 people. They share how many meals should they have ordered to have just enough food for 12. Okay, so 12 meals, that's enough for 18 people. Okay, so we want to know how many meals are enough for 12 people. Okay, here is an example of cross-multiplying, right? We're going to cross-multiply for this. So we're going to say 12 times 12, divide that by 18. 12 times 12, 144, and then we're going to divide that 144 by 18. Right? That's the same as dividing 9 by 72. It's the same as dividing 3 by 24. And so our answer is 8. 3 divided by 24 is 8. Okay, moving on. We have Mrs. Hamilton's 8th grade class. 3-person basketball tournament, and there's 4 people. And how many ways can the 3 starters be chosen? Okay, so we've got Lance, Sally, Joy, and Fred. And whatever 3 are picked, one of them is going to be left out, right? So either Lance, Sally, and Joe are picked and Fred's left out, or maybe Lance and Joe and Fred are picked and Sally's left out. So there's always one person left out, and another way you can think about that is that there's 4 different people that could be left out. So there's 4 people who could be left out, so that's 4 ways to have 3 people on the team. There's 4 ways to leave one person out. So 4 is our answer. Okay, another question with the basketball team. So the losing team of each game is eliminated from the tournament, and 16 teams compete. How many games will we play to determine the winner? All right. So every game that's played, one team is going to lose. And we need 15 teams to lose to get a winner, right? So if one team loses per game, and we need 15 teams to lose, that's 15 games that need to be played, right? One for determining each loser. Okay? After Sally takes 20 shots, she has made 55% of her shots. After she takes 5 more shots, she raises her percentage to 56%. How many of the last 5 shots did she make? All right. So she's made 55% of 20. What's 55% of 20? Let's see. We can multiply 20 by 0.55 to figure that out. Okay, that would be 11 with 2 decimal points. So that's 11. Sally made 11 out of 20 shots. Then, after she takes 5 more shots, so now she's taken a total of 25 shots, she's made 56%. That's an improvement. So, what's 56% of 25? Do the same thing. 0.56 times 25. And that is 14. Okay, so if we went from making 11 to making 14, that's an increase of 3 shots. All right, awesome. An athlete's target heart rate is 80% of the theoretical maximum heart rate. Okay? And the maximum heart rate is found by subtracting the athlete's age in years from 220. The nearest whole number, what is the largest heart rate of an athlete? What is the target heart rate of an athlete who's 26? Okay? So we find the maximum by subtracting 26 from 220, right? So that's going to be 194. Okay, so that's their theoretical maximum, and we want 80% of that. So to find 80%, we can multiply 194 by 0.8. I encourage you to do this on your own as well. So that is 155.2. We want to the nearest whole number, so that's closest to 155. Answer choice B. Okay, find the number of two-digit positive integers whose digits total 7. Okay, so that means, like if we had the number 16, for example, we would go 1 plus 6, and that's an example of the two-digit number whose digits add up to 7. All right, well, let's do some trial and error. So we know that that's the only two-digit number that starts with a 1 that's going to add up to 7, right? Because if we had like 14, that's going to add up to not 7. The only thing that'll make it 1 add up to 7 is 6. So we did that. What if the number starts with 2? Well, 2 plus 5 is 7, so that'd be 25 is our next number. What about 3? That would have to be 4, 43, 52, 61. And then you might be tempted to be like, that seems pretty good. It seems like we're done. Don't forget, we also have 7D, right? 7 plus 0 equals 7. So that is a total of 7. All right. The average of the 5 numbers in a list is 54. The average of the first 2 numbers is 48. What is the average of the last 3? All right, so let's call our numbers A, B, C, D, E. So it says here that the average of them is 54. So that divided by 5 is 54. We can find what they all add up to by multiplying by 5, right? So A plus B plus C plus D plus E, that equals 54 times 5, which is 270. Okay, we know the first two average 48. So we can multiply that by 2 to figure out what A plus B equals. 48 times 2 is 96. So A plus B is 96. So now we know 96 plus C plus D plus E equals 270. Okay, well, we want C plus D plus E to find the average of those 3 numbers. So we can subtract 96 from both sides of the equation. 270 minus 96, that would be 174. 174 divided by 3, right? Because we've got C plus D plus E. That would be 58. Answer choice D. Okay, we've got handy Aaron. He helped a neighbor for 1.25 hours on Monday, 50 minutes on Tuesday, specific amount of time on Wednesday, half an hour on Friday, and he's paid $3 per hour. How much did he earn for the week? All right, so we've got 1.25 hour for Monday, 50 minutes on Tuesday. I think this might be easier if we turned it all into minutes, right? So how many minutes is 1.25 hour? We know that 1 hour is 60 minutes, and then a quarter of an hour would be 60 divided by 4, so that would be 15. So we've got 60 minutes and 15 minutes for Monday, 50 minutes for Tuesday. So on Wednesday, we got from 8:20 to 10:45. So from 8:20 to 9:20 is an hour. From 9:20 to 10:20 is 2 hours. So that's 120 minutes for 2 hours. And then from 10:20 to 10:45, that's another 25 minutes. Okay. And we got half an hour on Friday. Half an hour is 30 minutes. 60 divided by 2 is 30. So how many total minutes did Aaron work? Adding all of these up, that's 300 minutes. Okay, how much is that in hours? 300 minutes divided by 60 minutes per hour, that is 5 hours. He's paid $3 per hour for 5 hours. 3 times 5 is $15. Kids, advocate for yourself. If you're doing yard work, try to make more than handy Aaron. You deserve it. Okay. We've got numbers 2, 4, 6, 9, and 12. The largest number isn't first, but is in one of the first 3 places. The smallest isn't last, but is in one of the last 3 places. The median isn't first or last. And we want the average of the first and last numbers. All right, let's think about this. Here's our 5 spots. So the largest, that's 12, isn't first, but it's in one of the first 3 places. So that means 12 is either going to go in the second place or it's going to go in the middle place. Okay? The smallest, that's -2, isn't last, but it's in one of the last 3 places. So -2 is either here or here. Okay? The median isn't first or last. So the median, that would be 6, is either here, here, or here. Okay, so that means that those 3 numbers, 12, -2, and 6, they cannot be the first or the last. So the only numbers left to be the first and the last numbers are 4 and 9. So 4 is either the first or the last, and then 9 is either the first or the last. So that means that 4 and 9 are first and last. We don't know if it goes 4 and 9 or 9 and then 4, but either way, we can find the average. 9 plus 4 is 13, divided by 2, that is 6.5. Okay, we got Nikki. Nikki usually leaves her cell phone on. Okay, if her phone is on but she's not using it, the battery will last 24 hours. If she's using it consistently, the battery will only last for 3 hours. Okay, since her last recharge, her phone has been on for 9 hours, and during that time, she used it for 60 minutes. Okay, if she doesn't talk anymore but leaves the phone on, how many more hours will the battery last? All right, so we know that the phone has been used to talk for 60 minutes. That's 1 hour, right? And we know it only lasts 3 hours if it's being used to talk with. So it's been used for 1 out of 3 possible hours to talk. So that means we've already lost a third of the battery, right? 1 hour, that's 1/3 of 3 hours. So we used 1/3 of the battery. That's 33.33%, right? And the phone has been on for 9 hours. So for 8 other hours, she's been using it not to talk, but it's just been on. So if it's on but not being used, the battery will last for 24 hours. So we've gone for 8 of those 24 hours, but not talking, right? 8 of those 24 hours have already been used for the not talking part. So that's another third, right? 33.33 of the battery time has been used again. So now we've got about 67% of the battery time has been used. So we want to know how many more hours will the battery last if it's not on. Okay, we know that at a full battery, it will last 24 hours, not on. But we don't have a full battery. We only have a third of the battery left, right? Because we've already used 2/3 of the battery time. So 1/3 of 24 hours, that would be 8 more hours. 24 divided by 3 is 8. All right. We've got friends with different ages. So one of those statements is true. So let's do some guesswork. Okay, let's say that Bill is true. Let's do a hypothetical. If Bill is true, that means he's the oldest. That also means that Amy is not the oldest, right? And if Bill's the oldest, then we know that that must be true too. Oh wait, we know that only one of the statements is true. So that means Bill is the oldest. That must be false. Otherwise, we have 2 true statements, which we know we shouldn't have. Okay, so Bill is not the oldest. That's false. Okay, what if we said that number 2 is true? Let's say that Amy is not the oldest is also true. So that means Bill is not the oldest and Amy is not the oldest. So out of our 3 spots, Bill is either second oldest or third oldest. Amy can't be the oldest either, so she's in second oldest or third oldest. That means Celine has to be the oldest if Amy is not the oldest and Bill is not the oldest. So Celine is not the youngest. That would be a true statement because based off of our stuff, that means she's the oldest. But that can't be true either, right? Because we've already decided that there can only be one true statement. So that's wrong too. So that means our first statement is false and our second statement has to be false. So that means our last statement is true. Okay, Bill is the oldest is false. Amy is not the oldest is false. So Amy has to be the oldest. Celine is not the youngest is true. So Celine has to be the middle kid. And then Bill is the oldest is false. So Bill is the youngest. So from oldest to youngest, we've got Amy, then Celine, then Bill. Answer choice E. Okay, what's the area of the quadrilateral shown below? So what we're going to do for this is we're going to find the area that's not the quadrilateral, right? Because our quadrilateral is kind of messy, and it'd be kind of hard to find that area. So we'll make it a little nicer. So we know the area of our entire grid. That's what are the dimensions of that grid? About 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10 by 10 grid, so the total area is 100. Okay, let's start subtracting. Here, we've got this triangle. That has base 4 and height 5. So that triangle has area, remember, base times height over 2. 5 times 4 is 20, divided by 2 is 10. So that triangle has area 10. Okay, what about this triangle over here? It's got height 10 and base 6. Base times height, 10 times 6, divided by 2. 60 divided by 2 is 30. So this part has area 30. Okay, what about this triangle here? That's got base 7 and height 6. Base times height divided by 2, 7 times 6 divided by 2 is 21. Okay, over here, we've got a rectangle with base 3 and height 5. 3 times 5 is 15. Okay, and lastly, we've got this teeny triangle in here. It's got base 3 and height 1. 3 times 1 divided by 2 is 3 over 2. Okay, so what's our total outside area? We've got 15 and 21 and 30 and 10 and 3 over 2. Adding that up, 76 and 3 halves, or we could say 77 and 1 half. Okay, so the rest of the area, if we found the area of all of this space, right, the rest of the area belongs inside the quadrilateral. So 100 minus the outside area, 77.5, is going to be our inside area. So that would be 22.5 as our thing. And here it is, answer choice C, 22.5. Okay, we've got hexagonal tiles. Okay. So we're saying if we add white tiles to the outside of that, what will the difference between the total number of white tiles and the total number of black tiles in the new figure be? Okay. Let's think about this. So we have one inner black tile, right? Okay, then outside of that, we've got 6 white tiles. So 1 black tile, then 6 white tiles. And then after that, in the next row of black tiles, we have 12, right? Okay. What about a next layer of white tiles? We could kind of try to draw it in. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So we've got 18 plus 6, that's 24 white tiles, and 12 plus 1, that's 13 black tiles. And we want to know the difference between the number of black and white tiles, so that's 24 minus 13, which is 11. Answer choice C. Okay, 2 600 milliliter pitchers of orange juice. One pitcher is a third of the way full, and the other is 2/5 of the way full. And then water is added to fill each pitcher completely. Then both pitchers are poured into one large container. What fraction of the mixture in the large container is orange juice? Okay, so in our first pitcher, let me draw this out. We've got 1/3 OJ, so we'll do 1/3 orange juice. So that means water is going to be added, 2/3 water. Okay? Our other pitcher has 2/5 orange juice, 2/5 orange juice, and then 3/5 water. Right? And now they're combined. So they're poured into one large container. And remember, both pitchers are the same size, right? So now we've got, okay, let's figure out how many milliliters of each fluid is in each pitcher, right? So we've got 1/3 of the 600 milliliters is orange juice. So 1/3 of 600, that's 600 divided by 3. So that's 200 milliliters. And then 2/3 is going to be 1/3 plus 1/3. That's 400 milliliters of water in the first one. Okay? In the other pitcher, we've got 2/5 is 600 milliliters. 2/5 of 600 milliliters. So that's 600 divided by 5. That's 120 times 2. So that's 240 milliliters of orange juice in the second one. And 460 milliliters of water. Sorry, 360 milliliters of water. Okay, so when we combine the two pitchers, suddenly we're going to have 600 plus 600, that's 1,200 milliliters of orange juice. And we want to know what fraction of that is going to be orange juice. So we've got the 200 from the first pitcher plus the 240 from the second pitcher. That's going to be 440 out of the 1,200. Can we simplify that? Yep, we could do 44 over 120. We could divide that by 4. 11 is 44 divided by 4. 120 divided by 4 is 30. So 11/30 is orange juice. Answer choice C. Three friends have a total of 6 identical pencils, and each has at least one pencil. And how many ways can this happen? Okay. So we've got 3 friends and 6 pencils. So let's draw our pencils. Here are our pencils. And we want to know how many ways there are to divide these among 3 friends. So let's have friend A, B, and C. We know they each have 1 pencil, so that means there's 3 more pencils to go between them. So let's figure this out. Well, we could have the other 3 go to friend A, or all 3 could go to B, or all 3 could go to C. So that'd be if they didn't split it up anymore. So friends having 3 more, having one friend having 4 and 2 friends having just 1, that could happen in 3 ways, right? That'd be if A had 4, Another way is if B had 4. Another way is if C had 4. Okay, what if one friend has 3 pencils? So A has a total of 3. Now there's one more pencil to split between B or C. So either B or C could have it. So there's 2 ways to do it once one friend has 3 pencils. So there's 3 ways somebody could have 3 pencils times 2 ways another person could have 2 pencils. So that's another 6 ways. Okay? And then the last way is if everybody just got one more pencil. Nobody had 3, nobody had 2. Nobody had 3 or 4. They all have 2 pencils. And that could happen in one way. So the total number of ways to split up the pencils between the friends is D, which is 10. Okay, we have 5 friends competing in a dart throwing contest. Each one has 2 darts to throw at the same circular target, and each score is the sum of the scores in the target's regions that are hit. Okay, we've got 1 through 10. Okay, and each throw hits the target in a region with a different value. We got 16, 4, 7, 11, 17. And we want to know who hits the region worth 6 points. Okay, so let's figure this out. Let's start with Ben, because he has the smallest score. So he got 4 points. So what are the ways that he could do that? So how we got up to 4, we could go 4 plus 0, 3 plus 1, or 2 plus 2. And only one of these is a legitimate way to hit the darts, right? There's no 0 region, so 4 plus 0 isn't impossible. And there's only 1, 2 region, so 2 plus 2 is impossible. So Ben must have gotten region 3 and region 1. Okay. What about Cindy? She has the next smallest. So how could you get 7? You could do 1 plus 6, 2 and 5, or 3 and 4. Right? Well, we know Cindy couldn't have gotten the 1 and 6 because Ben already got into region 1. And she couldn't have 3 and 4 because Ben also used region 3. So that means Cindy must have hit in regions 2 and 5. Okay. Next is Dave. For 11, we can have 1 and 10, 2 and 9, 3 and 8, 4 and 7, 5 and 6. So 1 and 10 is out because of Ben. 2 and 9 is out because of Cindy. 3 and 8 is out because of Ben. And 5 and 6 is out because of Cindy. So that means Dave must have hit the region 4 and region 7. Okay, so now we're left with only regions 6, 8, and 9. And 10. Okay, we've got Alice, who scored 16 points. So you can do that with 6 and 10, with 7 and 9, or 8 and 8. Okay. Well, Alice could have used 6 and 10, because neither of those numbers is claimed. And she could not have used 7 and 9, because Dave already used 4 and 7. So the 7's already taken. So that means Alice must have used region 6. We've got a whole number larger than 2 leaves a remainder of 2 when divided by each of the numbers 3, 4, 5, and 6. The smallest such number lies between which 2 numbers? Okay. Larger than 2 leaves a remainder of 2 when divided by 3, 4, 5, and 6. So, let's find the smallest number that's divisible by 3, 4, 5, and 6, and then add 2 to it, right? Because we need something that's 2 more than a factor of all of these. So we need a number that's 2 less than it would be a factor of all of those, right? So if you take our mystery number, 2 less than it would be a multiple of all of our numbers. Okay? So what's a number that's a multiple of 3, 4, or that's divisible by 3, 4, 5, and 6? Okay. Well, it needs to be a multiple of 3. It needs to be a multiple of 2 twice, right? Because we've got 4 has 2 multiples of 2 in it. It needs to be a multiple of 5. And then it's already going to be a multiple of 6 right? Because for it to be a multiple of 3 and 4, it's already got a 2 and a 3 accounted for, which will always make a 6, right? So 3 times 2 times 2 times 5 is a multiple of 3 and 4 and 5 and 6. Okay? Multiplying those four numbers together, we get 60. Okay? Adding 2 to it is 62. So 62 is two more than a multiple of 3, 4, 5, and 6. And that's between 60 and 79. Answer choice B. Okay, 2/3 of the people in a room are seated in 3/4 of the chairs. Ooh. The rest of the people are standing. If there are 6 empty chairs, how many people are in the room? Okay. So there are 6 empty chairs. And we know that 3/4 of the chairs are occupied by people, so 1/4 of the chairs are empty. So 1/4 is 6 chairs. So 1/4 is 6. 1/4 of the chairs is 6. So how many total chairs are there? Well, that would be 1/4 times 4, right? So the number of chairs would be 4 times 1/4 of the number of chairs. So that's 24 chairs. Okay? We also know that 2/3 of the people in the room are seated in 3/4 of the chairs. So if 6 chairs are empty, we want 3/4 of the 24 chairs. So that's all of the chairs minus 1/4 of the chairs, 18 chairs. So 2/3 of the people are in those 18 chairs. So that means the 18 equals 2/3 of the number of people. Okay? So if 18 is 2/3, how many is all of it? We can multiply 18 times, no. So if 18 is 2/3, we can find 1/3, right, by dividing that by 2, right? So 9 is 1/3 if 18 is 2/3. Multiplying that by 3 will give us 3/3, which is 1. So 9 times 3, 27. That gives us 3/3, or all of the people. Answer choice D. Okay, we've got spinners that are spun. The arrow is equally likely to land on each number. What is the probability that the product of the two spinners is even? All right, here's something important to remember. Even times even is even. Even times odd is even. Odd times even is even. Odd times odd is odd. Okay, so we want the probability that they're even. The only time that's not going to happen is if we get 2 odd numbers. So what are the chances that we get 2 odd numbers? Well, on A, our odd numbers are 1 and 3, right? So there's 2 out of the 4 ways to get an odd number on A, and on B, 1 and 3 are odd. So there's 2 out of 3 ways to get an odd on B. So that's our chance. 2 over 4 times 2 over 3 is our chance of getting an odd product. So multiplying that together, there's a 4 in 12 chance of getting an odd number. Okay, so if there's a 4 in 12 chance of getting an odd number, there must be an 8 in 12 chance of getting an even number, right? Because 4 over 12 plus 8 over 12 is going to equal 12 over 12, which is, the whole thing, right? All of our possibilities are going to add up to 1. So there's an 8 in 12 chance of the product being even. Can we simplify 8 over 12? We can. We can divide the top and the bottom by 4, which gets 2 over 3, answer choice D. Okay. A party with single women and married men with their wives. The probability that a randomly selected woman is single is 2 over 5. What fraction of the people in the room are married men? Okay. So out of all of the women, 2/5 are single. So 3/5 of the women are married. Okay? Why don't we find an example? So let's say there are 5 women, and 2/5 of them have to be single, right? So there's 2 single women. So that means 3/5 are married. So there's 3 married women. Married. Okay, so each of these married women is going to have a husband. So 3 married women, then there's 3 husbands. So what fraction of the people in the room are married men? That would be the 3 husbands out of a total of 3 plus 3 plus 2 people. That's 8 total people. So 3/8 of the people in the room are married men, right? Because 2/5 are single, so 3/5 must be married. Each of those married people has a husband. Yep, so 3 husbands for a total of 3 out of 8 people are married men. Okay, Tess running counterclockwise on a rectangular block. She lives on corner J, going counterclockwise. Which graph could represent her straight line distance from home? Okay. So at first, her distance from home is increasing, right? Then, like as she goes from J to K, she's getting farther and farther away from her home because she's going exactly away from it. Like she's taking the fastest path away from her home. Then, as she goes from K to L, her distance from home is still increasing, right? She's getting farther and farther away from home, but she's not going as far away, right? She's decreasing that distance slowly. So she's going far away quickly and then far away not as quickly. Then, from L to M, she's getting closer to home. It's not very fast. She's not taking the straightest path to get home, but she's still getting closer to home. And lastly, from M to J, she's going straight home, like as fast as possible. Okay, we did our little drawing, and that looks really similar to graph D, right? It's showing all of the stages of her travel. So that is our answer.